Hi all, my name's Braxton. I'm here to talk to you about the project. Now I'm sure you've all heard about this project. This big, looming software engineering task on the horizon. Maybe you heard about it from your friends, maybe you read about it on Rate My Prof, maybe you heard it was a lot of work, really big, bigger than anything you did in 210, and I'm here to tell you that it's all true. Yes, it's big and it's kind of difficult, but it's also very fun and it can be very rewarding. And I wanted to get you acquainted with it. So today we're talking about the project and checkpoint 0, because that's what you need to do most immediately is checkpoint 0. So, what are we making? Insight UBC is a system that stores historical data from course sections at UBC. So that's things like, what was the course's average? How many people were enrolled? When did it happen? Who was the instructor? This data comes from a zip file, meaning your system should be able to open up a zip file, look around, find the important data, and store what is necessary. Save it somehow. It also supports a query language, which allows users to ask questions of your system. Like, for example, what are all the courses at UBC that had an average of above 97%? This query language isn't done in natural language. It's not even a textual-based language. It's written using JavaScript objects. And you'll learn more about those in the TypeScript lecture delivered by James. Lastly, it should act as the backend for a website, but this isn't something that you need to worry about right now. This is a problem for future you, the you of 8 to 9 weeks from now. A lot of you are probably also concerned about what we're making it with, and it's primarily written in TypeScript. At the very end, there's a little bit of JavaScript, and in the middle, there's a little bit of HTML, but you won't be writing any of the HTML, which is why it says kind of. Just maybe reading it a little bit. Node.js is the engine that we'll be using to execute your program. And Yarn is a package manager, meaning that we'll be using it to download, gather all the dependencies that will be used by your system. Mocha is a test framework, and Chai is an assertion library. So together they're analogous to JUnit, like you would have used in 210. Git, again, like you would have used in 210, is a version control system. As for IDEs, we recommend IntelliJ, not Community Edition, specifically Ultimate Edition, as it doesn't only support Java, but it also supports TypeScript and JavaScript, and Python and Ruby and Scala and many others. WebStorm is like IntelliJ, but it supports fewer languages, and it would suffice for this course. Visual Studio Code, it's small, it's lightweight, it's free, and it works, but it's not the one we officially recommend because debugger is not as nice as IntelliJ's. Now, I know a lot of you are probably looking at a lot of these tools and thinking, oh my gosh, I have to write an entire system in a language I've never seen before, and I'm here to tell you it's going to be okay. And I don't just say this as somebody who's TA'd this course many times and seen many students be successful. I say this because if you look at the code on the left, this is code you would have written in 210. And if you look at the code on the right, that's code you'd be writing for this class. Squint a little bit and take a second to convince yourself that this is the same program twice. Also, there are plenty of resources for the kinds of things that we're going to be engaging with this term in the project. Now, often you'll Google things for TypeScript and you'll get JavaScript resources and you'll think, oh no, there's nothing for TypeScript. But again, don't worry. The code on the left is TypeScript. The code on the right is JavaScript. Even more similar. The only real difference in this example is that the type annotations on the TypeScript side are missing on the JavaScript side. Anything you find that's a resource for JavaScript is immediately applicable to TypeScript. Well, you might just have to add a couple keywords here and there. Okay, back to the project. So what are its constituent parts? By the end of the term, a user should be able to interact with your system via some website. On this website, they should be able to ask a question like, which courses have an average above 97%? And when they hit the submit button, this question gets transformed into our intermediate query language as we described before. This is sent to the backend, which chews on some data. And where does that data come from? The zip file. Once the correct sections have been selected and sorted, it's sent back to the front end for presentation. As you can see, most of the complexity happens in the back end, meaning it's also prone to the most error, so it needs a really good test suite. And that's what you're doing for checkpoint 0, writing the tests for the back end, which you'll do during checkpoint 1, and you'll continue to iterate on it for checkpoint 2. Checkpoint 3, you'll be hooking it up to the front end. Most of the front end will be provided for you. You'll just need to hook it up and implement a couple stubs. You might be asking, why isn't it given to us all at once? Why is it broken up into these checkpoints? I mean, it's a huge project, and if we were to give it to you all right away, it could be overwhelming. So instead, we have a rolling spec, and at every suggested checkpoint deadline, we have a list of things that we think need to get done. Additionally, you'll be working on this with a partner, most of it, so you'll have somebody to work on it with you. The only one that's to be done individually is checkpoint 0. So, checkpoint 0 is, again, a test suite that should cover the backend implementation as specified by checkpoint 1. You do this one alone, and the way we're going to calculate your grade is we'll take your test suite and run it against our implementation. Then we'll generate a coverage score, specifically a statement coverage score, and we'll use that to generate your grade. So if you get 100% statement coverage on our implementation, you'll get a grade of 100%. Now, immediately what do you need to do? Visit Classy. This is where you'll get your grades eventually and access your repo. Many of you have already done this. You just log in with your campus-wide login. What I want you to do right away is clone your repo and write any unit test. You can copy and paste the starter test and make a couple tiny cosmetic changes. That's fine. Commit and push and call Autobot. Now, if you haven't done this in 2.10 before, there are many resources on the website about how to do this. But the reason why I want you to do this right now, there are two reasons. Reason number one is I want to make sure that your development environment is set up correctly. It's easier to iron out those silly issues right now than the day before the deadline. And reason number two is I want you to get an idea of the turnaround time. How long does it take to iterate and get feedback from Autotest? If you want to do well on checkpoint 0, well, the first thing you'll need to do, and I mean it sounds silly, but read the instructions very slowly. And when you're done reading them, the first thing you should do is read them again. There's a lot in there. For every statement in the spec, ask yourself, have I validated this? Almost every statement, almost every sentence in the spec says something about how the system should be. Meaning almost every statement, barring redundancies, could be turned into a test case. The next thing is don't try to brute force it. And what I mean by this is there are students who got 100% on checkpoint 0 writing only 60 tests. And unfortunately, there were other students who didn't get 100% until they had written 400 tests. And I want you to be on the 60 test side. Think about it this way. If you were to send to the system a string and then also send to the system a number, you're probably testing two different swaths of code. However, if you send to the system 20 different strings, there's a good chance you're hitting the same code 20 times. You'll talk more about equivalence classes in the coming weeks. And lastly, another one that sounds straightforward is Google things. One of the most important things I learned in this class was not just how to get information from the internet quickly, but how to very quickly discern between what is valuable and less valuable information when scouring through Stack Overflow posts and API documentation. Everything you need to be successful in this course is either on the course website or 4 Google searches away. If you have questions about TypeScript specifically, James has already posted a very helpful lecture on an introduction to TypeScript. If you have more questions, please follow up on Piazza and we'll be there to answer. Thanks.